Hello and welcome to this talk about contract-driven development for event-driven architecture. My name is Krishnan. I'm the co-founder and CTO at Specmatic. I'm a transformation advisor, coach, and trainer, and I also help a lot of organizations with their API governance strategy. Joel, can you introduce yourself?
Hey, Joel Rosario, co-founder, chief scientist at Specmatic. I've had over 2 decades of experience in product companies working with APIs, and it's pretty much my bread and butter nowadays.
Thanks a lot, Joel. So let's quickly dive into the talk for today. And we are talking about contract driven development for event driven architecture. So let's have a look at a lay of the land in terms of a architecture diagram first, so that then we can use that as reference during our demos and further analysis of what we're trying to achieve today. So let's say we have a system which is like an order service, and that order service is exposing or rather interacting with other services via Kafka. Uh, and there's a topic called place order on which it receives messages. And once it receives order details, it pushes another message on the process order topic. And thereby, like, other systems can pick that up. And for example, a fulfillment service or maybe a notification service can pick that up and run with it. Likewise, whenever there is a request to cancel an order, a message is received by order service with the details of what order to cancel. And subsequently, order service processes whatever needs to be done and pushes it down to the process order, process cancellation topic, so that other systems can do the needful from their point of view. So this has a typical pattern to it, right? For every message which you put as a request, order service seems to come back to us with a reply. And that's the same with the cancellation also. There's a typical request reply sort of pattern going on here with order service. And we wanted to model this and build this out and use async API specification for the same. And that's what we did. So initially we started when we built the system about a couple of years ago, we built it out with Async API 2.6. So let's look at a live demo of how this all works out with Async API 2.6 itself, right? So let me quickly switch to my code. And I have my Async API 2.6 spec here for this particular service. And let me quickly go into the details. It's typical Async API specification. I'll go into the preview mode for it. Again, shout out to Pavel and the Async API team for having the preview mode for Async API itself within IntelliJ. So it's got a bunch of topics, all that we saw on the diagram, which is the process order, cancel order, process cancellation, and the message payloads for each of these things. So, for example, if you want to look at place order, takes the order items which needs to be picked up and run, right? So I'll just close this out, and now let's actually see the application that's built out here. This app is a straightforward Springboard application, and it is supposed to model whatever is there in this API specification, right? But why take my words for it? Let's try it out. Let's boot up the application and run the async API specification as a test and see if it actually satisfies all these cases. So first, let me bring up Kafka itself on my local machine. So I have a simple Docker compose to bring up Kafka and Zookeeper, and that's up and running, as you can see, on my Docker desktop. And once that is done, I am switching over to the next step, which is to start the application itself. Now this app is starting, and it goes on to connect with the Kafka broker here. And as you can see, it has got a consumer group. It has joined and it has started the application. All right. So now, obviously, we have the async API specification itself, which I just showed you. So I'm going to say Specmatic Kafka test and then pass in the async API specification. So this looks fairly straightforward, right? So let's run this and see what happens. And voila. Sorry, one moment, please. One moment, I will just clean this up. It's always like the demo gods sometimes tend to have. Let me quickly kill this and go to the Docker, make sure I delete any instances that I have, and then start over, start up my Kafka, start my app. Okay, we have the app running and we have this running. So all I need to do is now to run Specmatic Kafka test and async API 2.6 specification. And let's run this. And there we go. So what's a good live demo without a glitch, right? So you got this demo and then you ran the test and it says two successes. Let's understand the details of this test itself. I'm going to launch this up here. And this is the test report that we are seeing after the test ran. So obviously there were two topics, right? Two sets of topics that you saw, a new order and a cancel order. So obviously we're sending a new order here, the details for the order itself, and then the reply topic comes back with the order ID and what happened with it, the total amount for the order. And subsequently there's a cancel order here, which again takes the payload, the 10 ID 10 from here, pushes it here and says, I want to cancel this order. Subsequently, you get back a reference number for the cancellation and says the cancellation request is now completed. So how did all this happen? Like, how did we put together the request and reply? Async API 2.6 really does not have native support for request reply pattern, but what we did is used examples as a way to feed in the test data to get this sort of a request reply thing orchestrated. Now that we've seen that this application is actually able to do a test, I mean, like we're able to run the Sync API specification as a test using Specmatic and verify that our application is already satisfying the spec. What can we do next? So that's when I will go back to my slide deck and say, yeah, I would like to migrate from Async API 2.6 to 3. Why? Like I already said, 2.6 does not have native support for request and reply patterns. So when 3.0 came out, we were really, really excited that this is now a first class citizen within the specification itself. So we wanted to start using this. And then, of course, there's correlation ID, which you can actually, explicitly define which message is associated with which response, which is important in a request reply context, and also the support for dynamic reply, which is also an important capability among many other capabilities that come with 3.0. So we certainly wanted to upgrade, and but that said, how do we migrate safely without introducing unintended change in behavior? Now, I want to emphasize the word safe here. It's not about just moving from 2.6 to 3, right? I certainly want to change. I only want to move in terms of the syntax of the async API specification, but the order service itself is not changing in terms of its behavior, right? So I should not unintentionally introduce any change in the process of migration. How do I ensure this safety? So that is the big question, right? Now, in order to do that, this is where we came up with a clever little trick, which is you already saw that Specmatic can run, given an API specification in it, it can run it as a test. But what Specmatic can also do, interestingly, is given an async API specification, it can run it as a mock, right? I can boot up, in this case, I'm demonstrating with Kafka, but then any other mechanism that async API supports, for example, Google PubSub or MQTT, accordingly, we could start a mock in my, or a test container or something like that, where we can start up a mock server and emulate the behavior of the system that will implement that async API specification. So what we're doing here is, let's say we took the 2.6 spec, converted it to 3.0, we run a mock server based off of that. Now what we do then do is take the 2.6 spec, and you all are already aware that I can take the 2.6 spec and run it as a test, right? But this time I won't run it as a test against any real application. I run it as a test against the mock server, which is emulating the behavior as per the 3.0 version of this API specification. Technically, if there is no behavior change, it's only a syntax change. When I send the request and that system, the mock returns with a reply, I should be able to verify it. And if all this works out, which means I can safely say behavior wise, there is no change between the 2.6 and 3.0 spec. And that's the beauty of being able to do like backward compatibility testing itself, right? Now, one might say that backward compatibility testing, we always have like, diff tools and whatnot, but diff tools can only go so far. But when you're trying to do something like a migration from certain version of spec to another version of the spec, you want to make sure there is zero change in behavior, right? And the way you can do that is a full compatibility check you could do by running one as a test and one as a stub and verify the same, right? So enough talking in terms of what is this. I want to demonstrate this piece itself, and then we'll get into the details further, right? So let me quickly go back to my IntelliJ, and just to be sure, I'll kill everything that we started for the previous demo, remove all of these windows, and yeah, so there we go. It's all out of the way. Now let's start with this step, right? So this, I'm using the async API CLI to convert the 2.6 spec to a 3.0 spec. As you can see, I only have a 2.6 spec at this point, right? So what I'm going to do is async API convert and move it over to a 3.0 spec, and you already have a 3.0 spec, and let's look at it. Beautiful. There's a celebratory note at the top, which I like very much. I'm going to knock it off here and then save it. So we have a 3.0 spec. Let's get back to our demo. What I'm going to do now is what we saw in the picture, right? Which is I'm going to take the 3.0 spec here, which we generated, right? And run that as a virtualization, like a mock server, right? Service virtualization. I'll kick that off. And as you can see, it's listening onto topics, right? Now what I'm going to do is take the 2.6 spec and run it as a test. This you're all familiar with already. So I'll kick it off. Now, obviously, because this is a test, it's going to drop messages onto the mock server and then expect that the mock server reply on the respective topics, and thereby look at it, how whether the replies are appearing on the correct topics and whether they are compliant with the spec itself, and then go from there. Now, why is it taking some time here? What's going on? Any possible guesses? Okay, we have two failures. Let's understand what these failures are, right? So I'm going to open this report. Earlier, you saw the report when I ran it against the real application. It was all green, it was succeeding. But this time it says, I sent a message, there's the reply is red. Let's look at what the issue is. It says, did not receive expected message on topic, process order, expected such and such. And likewise, here it says, did not receive a message on cancellation, this is such and such, right? So this is the current situation, correct? Now what do we do? Okay. Why is this happening? Let's look at the 3.0 spec itself. I will kill this mock server for a moment. And yeah, it's down. Let's look at the 3.0 spec and analyze this in greater detail. So I will minimize this. Yeah, okay. So here's our place order, process order, cancel order, process cancellation. Now, Async API CLI has done a great job in moving over all the 2.6 constructs to 3.0. But because 2.6 did not really natively support request reply pattern, the converter does not know how to make a request reply pattern here, right? Out of this, it's up to us in order to achieve that particular, in order to achieve that, right? So what I'm going to do is go under operations and then set it up manually. So for place order, I know that process order is the reply. So let me knock these two lines off. I'll say this is the reply, and I'll indent this according to the syntax. So it appears, the process order appears as a reply channel to the place order, right? And likewise for the cancellation, I'm going to knock off these two lines and then say reply here, and then of course like indent these four lines here, so that we are clearly saying that process cancellation is the reply channel for cancel order, right? So let's again look at the preview, make sure it's all looking good. So here's the payload. It says this is the reply. So for place order, the reply is the process order. And beautifully enough, like the preview has already picked up the pattern, and that's why it's showing us that the request reply pattern is already established. But again, we don't have to take at face value, right? Let's test it. And that's the only way to ascertain anything is working perfectly. So let's repeat what I just did, which is run the 3.0 spec as a virtualization, which is mock server. I kicked it off. And this time around, you also see that now the Specmatic mock server, the Kafka mock server, has already started listening on these four topics. So that's a good, healthy sign. Last time it was showing an empty parenthesis, if some of you may have paid attention to that. So now it is showing you all the four topics on which it's listening, right? Now, let me go to this other piece and run the test now, right? And let's see what happens. And what do you anticipate? Before you can even answer, the tests are done. And here's the report, and it's all green. So again, this time you see responses coming through. You see the particular order ID coming back, ID 10. I send the cancellation for that, and the response comes back here saying it's completed. Practically zero difference between 2.6 and 3.0 in terms of the messages, the interactions, the topic names, the behavior. It's only the syntax that change, and that's really, really critical. So once again, to emphasize and sort of recap what is important here, it is not just about what I demonstrated for async API specification, right? This became very, very critical for us at async API. I mean, mainly because we had a lot of API specs in 2.6 and we wanted to move them over to 3.0. And this is how we verified that we are not unintentionally introducing any mistakes, and also the request reply tie-ups and all are correctly done. Now this is also like something that you can extrapolate to other API specifications, maybe even open API. You're moving from 2.6 to 3.0 open API, or 3.0 to 3.1, or from 3.1 to the upcoming moonwalk. So you might want to make, you really, really need to make sure that you're not introducing unintentional behavior during those migrations. And that's true compatibility checking, right? You don't want to just depend on like some dev tool to, like, while they do their job to an extent, this level of sophisticated verification is only possible when you simulate the mocking and the testing across various versions of specifications, and again various evolutions of your own API. And that's the criticality of it. And with that, I will hand it over to Joel to now talk about what we can do with the Async API 3.0 spec that we have now generated and we have verified it's in order. And I'll hand it over to Joel to take it on from here and show us how we can use this as tests and other areas. Over to you, Joel.
Thank you very much, Hari. Before moving forward, and we're going to see a demo of this, I'd like to quickly run over the anatomy of a contract test. So let's see what is happening here with a contract test. We'd have a tool such as Specmatic that would run contract tests. We start up with an async API specification, which is really the heart and soul uh, of this endeavor. We then would start up the API, which is the system under test, locally. And that's important because we are shifting this feedback left, as Hari's been saying all this while, and getting all this feedback from the safety of the laptop. And then we start up Kafka. Kafka is what's needed because this is a Kafka application. Specmatic then reads the async API spec and loads the example data. And then, just before running contract tests, does a validation of the example data. And this is really important because Specmatic uses the example data as test data. It's going to use it as test data to run the contract tests, and the contract tests are going to be of no use if you really can't trust the test data. And so the test data needs to be validated against the async API specification in order for it to make any sense to use it. And this payload validation is critical, and Specmatic does it before actually running the contract tests. There aren't any other tools that do this at this point. And then the contract tests are kicked off. What does that entail? Specmatic now acts as a consumer to the API, which is the system under test. All right, so it sends a request to the receive topic, which in API, async API 3.0 parlance is the topic on which the system under test receives a request using a Kafka consumer object. That request then gets transformed, gets processed by a certain business logic in the application, which then in turn returns a reply to the send topic using a producer object. And that reply goes to the consumer, which in this case is Specmatic, which is running a contract test. And then Specmatic verifies this reply, several aspects of it, including the schema and the topic and acknowledgements and so on and so forth, and ensures that the reply is as per the specification. And this is good because if the test passes, it means the system under test was able to understand a request that matched the specification and was able to thereby return a reply that also matched the specification. And that means it's in safe territory. And in fact, Specmatic will run contract tests for all of the operations in the specification. And we would expect them ideally to all pass. But of course, if anything happens to fail, and we'll see what kinds of failures we could see in a demo shortly, it's all in the safety of the laptop. That's the beauty of it. Nothing has to be deployed. Topics, offset validations, counts, payload schemas, all of these things are verified, all from the safety of the laptop. So with that, let me jump into a live demo and show you how contract tests could run. To start off with, here's the async API specification. You've seen this before, so I'm not going to go through it. But if you remember, I was telling you that examples are used as test data. And let me show you, right here, here's an example. New order, its name is new order. And you can see this data over here. This is going to be used as test data. So let me actually first start up the Kafka broker, which will be needed by the application. There you go. Kafka broker's up and running. And then let's kick off the application next. Let's give that half a second. Okay, the application's up and running too. And now let's run the async API 3.0 spec as a contract test. Let's see what happens. Contract tests are passing, which is good. Let's just do the due diligence of opening up the report. We see the report's green. Wonderful. That's what we expected. And this means that the application adheres to its specification. That's great. But the interesting part is what happens when something drifts, something is out of sync, something's out of whack. So let's see. Let's take simple example with the spec, right? We know that, for example, price is supposed to be a number, right? We can see up here that price is a number right here, and this is a number. But excuse me, many is the time when we've made an honest mistake and made this a string, let's say USD. Right, and this is a string now. It's a price, perfectly valid data, not valid per the spec. We were expecting a numerical value here. And something's wrong with the data. We would not be able to trust the test if this data were to be used as, this example was to be used as test data and the test were to pass. So who's going to give us that feedback? Well, as you can see, Specmatic does that instantly. The tests don't even kick off. You immediately get feedback saying expected number actual was 2000 USD. Great. Thankfully, Specmatic saved us the hassle of discovering later in the day that our tests were invalid. Well, let's just fix that. That's good. Marvelous. We've get the beauty is you get this all of this feedback right here on the laptop. You don't have to wait for very late in the day. And this is test data. This is good because it means I can trust the test data to be used in my tests. And now the tests run. And what happens when the application drifts from the specification, right? So let me show you what that could look like. See here, send message on process order topic. This is where we send a response when an order is being processed. And what we're basically saying here is the status. We're saying status, order status processed. Quickly check the enum. The value is processed. But what is status really? If you just take a closer look a little bit further down, you realize that this status value is an enum. There's a fixed set of values, that it can be. And I suggest, for the sake of understanding what's going to happen, we do make another honest mistake. Let's say completed, right? We've done this so many times. This happens all the time. Okay. What we're going to do now is we're going to kill the application. Let's also kill Kafka. And now let's restart Kafka. Start the application next. Go. And now we have an application that is returning a response that doesn't match the spec. What's the earliest point we find that out at, right? Is it great to find this out in an environment? No. But we can find it out right here. Look at that. Right away, Specmatic complains, right? The message received on process order is invalid. We were expecting something along these lines, right? There were 4 values we got completed. The feedback came here. That's the beauty of it. So on the safety of your laptop, you didn't get this from a QA engineer saying it failed in my environment and broke 30 other applications depending on this. It's just right here on your laptop. You didn't even have to deploy or push code to your branch. It's all right here. Right, and if you scroll to the end, you see there was one failure there. It's just open this quickly. The due diligence of looking at the report, right? You see the error there. The point is that this is the way for you to get feedback for the provider, right? When someone's expecting a request, matching a spec and supposed to return a reply matching a spec, and they don't. Either they don't understand the request or they don't send a proper reply. You get the feedback right here, on your laptop from the safety of your laptop without even having to push a line to a branch. And this is good, but it takes 2 hands to clap, right? There are 2 parties. There are 2 parties in every integration. The provider has the consumer, and if the provider is doing all this work, what's the point? It's only half the battle won if the consumer doesn't do the same. All right, this is pretty easy to do. All we have to do is get the consumer to do the same thing. Well, let's see how that would work. Consumers use mocks, right? As I was saying earlier, we use the contract test, to simulate a consumer hitting a provider. But on the consumer side, the consumer uses a mock to simulate the provider. So the provider is what's being simulated here. How does that work? Well, you start with the 3.0 spec. That's always, the first thing. And then you have Specmatic, which is going to act as the mock. Specmatic starts up the in-memory Kafka broker, creates the necessary topics, and reads in the examples, which we've seen from the spec already. Does the payload validation again. Remember that the same thing that applied on test side applies to mock side as well. It's critical for examples to be validated when you're loading them as mock, because they're going to play a role here too, just slightly different. What's going to happen here is that how do you explain to you how examples are correlated, right? So we're able to relate request to response examples in the spec. So when Specmatic's mock receives a request that matches one of the examples, it then returns the corresponding example to the consumer. And for that, it's critical for the examples to be really solid. They need to really match the spec. You can't have the mock, starting up and accepting requests that don't match. And so this validation is critical. It's done right at the start. And the beauty is this is a completely agnostic, platform agnostic, wire compatible mock. It's wire compatible. You don't have to retool your application in any sense. It just, as far as your application is concerned, the consumer is concerned, it's talking to a Kafka broker. It's just a Kafka broker. So happens that there's Specmatic on the other end, which is faithfully mocking out the dependency of the consumer. The consumer doesn't even know. Don't take my word for it. Let's run contract tests, right? That's the nice thing. We just saw contract tests being run against the application. Well, if this really is a wire compatible mock, we should be able to run it against the mock itself. And to boot, we'll use the same spec. So now the same spec, is used on both sides. It's a kind of a loop test. And that way we prove that it's wire compatible because the spec kind of tests the mock. Well, let's see how that's going to work. So let me switch to my IE again. I'm just going to kill the application here. We don't need that. I'm going to kill Kafka here. We don't need that. Excuse me. And let's get into it. So I'm going to start the 3.0 spec as a mock server. Let's first see that happen. Right. The very first thing we're going to do is run the loop test, okay, that I just talked about. Let's run the loop test. Excellent. So my point has been proved. The tests have passed, and thereby we can certainly say that this is a wire compatible mock. The contract test has just sent messages to Kafka topics and read the corresponding replies and validated them. That's it. So this is a wire compatible mock. Just note that we didn't start up any other Kafka. The Kafka topics, if I scroll right to the top here, the Kafka topics were all set up by the mock itself. Nothing else was needed. It's self-contained. Okay. What happens if mock data, if any of the examples are out of sync? We've already seen this once before, but why don't we try the experiment again and say 2000 USD, Specmatic, accepted, rejected immediately. Exactly what we would want, right? You can't even start the mock. You can't, Specmatic doesn't even let you get away with it, right? You've got something invalid in the spec, it's caught, it's given to you right at the start, right? This is feedback as far left. Your application hasn't even started and you've already got feedback there's something wrong with the data on your spec, right? And all of this on your laptop, nothing to be deployed, nothing, this is the cheapest possible form of feedback you can get. You pretty much have just started the mock and it's died right there. Hey, that's great. Um, but that's not all, right? We need to try the other side as well. What happens if the consumer drifts like we did before? So first thing I'm going to do is revert this. So example drift we've taken care of. Now let me just start this again. The examples are back in line. Now we need to see consumer drift. I don't have a consumer application for you, but I've got something pretty nifty here called KCAT. Okay. KCAT is a Kafka client. I've got two panes open here. What's on the left pane is a consumer. We are going to, attempt to cancel an order. We've got process cancellation. So we just started that up. I'm going to be listening to the process cancellation topic. Okay, there you go. We've got no requests that have been sent. And now I'm going to send this message to the cancel order topic. So process cancellation was the reply topic, and cancel order is the receive topic, so to speak, on which the request will be sent. So here I'm going to send this request ID 10, and we immediately get the response back. Where did the response come from? As expected, let's quickly get back to the logs. Specmatic received a message on this topic. Let's send this back, and that tells us that this was the message that we received, that we sent in the first place, which the Specmatic mock received, and then it sends this response back, right? Which is what we see here, which is great. That's the happy path. Let's test the other side of it. What happens when a consumer, an admittedly buggy consumer, again with the best of intentions, maybe they had something like a GUID, in mind, or some sort of ID, and they send this out. We don't get anything back. What happens? Let's go back to the log. This is exactly what we wanted. So the log tells us clearly we expected a number. We actually got this string, and that's not something we can handle. We don't have an example for it. Never mind the example. This is wrong according to the spec. That's perfect, right? Because where would I have got this feedback without having a mock that honors the spec? If I had not done that, I would have set my own mock up and I would have actually gotten this feedback in an integration environment, or even worse, in production after deployment. But in this way, I get it without even pushing a single line of code to a branch. And that's really the power of the tools I've just shown you. And just stepping back, doing a quick recap, what we've seen is various ways to catch API drift of different kinds, right from the safety of the laptop without even having to push a single line of code to a branch. There's much more you can do with CI, but this is all happening right on the laptop itself. The feedback is nearly instant. You catch when your applications are out of sync, be it consumer or provider, you catch that instantly. When your examples are out of sync, whether being used as test data or mock data, that's caught instantly. And examples are also pretty important because they not only act as test data and mock data, which is where the validation happens, but they're also critical because they explain to you, what was in the designer's mind. So all these kinds of drifts are caught right on your laptop, all the way left, where it's safest and cheapest to catch them and fix them. With that, I'll hand you over back to Hari to tell you more.
Thanks a lot, Joel. That was indeed very, very helpful to look at what the async API 3.0 spec itself can do, right? And that's beautiful in terms of how much you can achieve just with the API specification. And just I'd like to touch upon one point which Joel has repeatedly emphasized, and it can't be said enough how important this is, which is the example in the API specification is being used as test data and stub data within the context of what we were demonstrating. But even from a point of view of education, when you are sharing your API specifications with your fellow engineers and your fellow organizations or teams, most of the education based on the slide, again, thanks to Frankel Commons for sharing this information in the conference, which is basically the fact that 66%, examples continue to be the best learning resource. I mean, even your code samples comes in at 32%, and that's definitely saying something, right? Now, if that is your main source of learning, and if that is out of whack, then I think that leaves a lot to be desired for, which is why it is important that early in the life cycle of your API specifications and in your while you're building applications, you need the feedback to make sure that your examples are in line with your spec schema itself, right? Otherwise, the first the person might be a person reading the API specification will be confused. Do I trust the schema? Do I trust the data? It's all very difficult. So again, calling out this important statistic here, and of course, it's also important from our own point of view to look at examples and see that they are in line. So that is one important piece. And the second point, which I'd like to call out, which Joel also talked about, is the drift, right? The drift is something that which is becoming quite popular now as a term in terms of API drift being called out at various levels. At least we have seen three important drifts, right? One is the consumer of the application drifting away from the API specification. The second is the API provider, the service implementation drifting away from the API specification. And the third, the important category here, is the example within the API specification itself drifting from the API specification, which is like extreme close proximity itself having a drift. So these are three drifts which we want to avoid, and we want to keep all of these pieces in lockstep. And that's where like we kind of come up with the tooling necessary to give that feedback early in the cycle to make sure that we don't have any of such drift and like nip it at the bud situation, right? So with that, I'll move forward and talk about contract driven development, essentially, which is API governance in a nutshell in the context of all that we've seen, right? So let's look at what API governance itself looks like. We particularly prefer starting with an API design first approach because we believe it's a strong way to, not just the technology aspect of it. It's important to have the communication, the people, and the interaction bit right to make sure that we're all collaborating with each other, the provider developer, the consumer developer, the solution architects, the security operations, infrastructure. All of these people have, we all play an important role in taking an API live and to use it effectively, correct? Which means for us, API specifications are the most important form of communication. Capturing those discussions over email or maybe over a Word document does not cut it. This leaves to a lot of room for ambiguity, which is why API specifications such as Async API, Open API, your GraphQL STL, or your protofiles serve an important role, both eventually as guidance mechanisms for your building applications, but also as unambiguous mechanisms for communicating what your API design decisions are, right? So we start with the API design first so that the design is not an afterthought of building apps, but rather a very intentional exercise. Now, if this is the source of truth for all our API architecture and design, how do we make sure that all of us are referencing the same version of it, right? Not should not be that I have an API spec sitting in a wiki page and another API spec lying in my email. Um, then again we have a drift, right? So where how do we make sure we keep it in a same place? So that's when we realize the best place to keep it is a Git repository. Ultimately, specification is a code, a piece of code, right? So code belongs in a version control system, and nothing quite like Git. We do not want to introduce anything like a broker, because that would be another liability. Someone has to keep that broker running and maintain it, and if it goes down, it becomes a problem in the critical path for your push to deployment environments. So instead, we are all familiar with GitOps. There's nothing new to be learned here, and we have very robust Git systems in most of our organizations. So why reinvent the wheel? So Git is the place where we keep it. Now, the beauty of keeping API specifications in a Git repo is the fact that now you have pull request. So which means all you can do is you have a new API specification to be added, or you're proposing a change to an existing API spec, raise a pull request. And you could then have a linter, tools such as Vacuum or Stoplight Spectral, which could run on that and give you feedback and make sure that all your API specifications are following your organizational standards and are consistent across the board, right? That's the beauty of having like one place to keep it. So which means all of us can agree and adhere to certain standards of how we name our API, topics and the parameters, etc., and what status codes are correct, what operation patterns we should be following, right? And then comes the piece about backward compatibility testing. Again, cannot emphasize enough how important this piece is. And you have seen how it really, really works out when you are trying to do migrations and make sure you're not unintentionally introducing any changes when you're moving from one version of the spec to the other version of the spec. And just to quickly recap, you take the newer version of the API specification and run it as a mock server. You take the existing version of the spec, which is inside your repo, and run it as a test against it, and thereby you get feedback immediately to say there is no issues, right? At this point, you've not even written a single line of code. It's just API specification versus API specification, which is the cheapest form, right? And you could do it on your local machine, failing which, of course, when you raise the PR itself has a pre-merge check to say that I won't even allow you to merge unless you either take one of the corrective actions, right? Either if you're intentionally introducing a breaking change, bump up your version, right? Or if you really unintentionally introduce a change, maybe then you can course correct and say maybe make it a backward compatible change, or maybe you've identified an issue and you could resolve it. And of course, you do want to have some sort of a oversight from a human point of view, right? So you have the important the team members from your side form a committee around it and have a review process, finally do a once over and then approve the pull request, and then get it into the central contract repository. Now, we want to maintain the sanctity of your API specification, which is why we want such rigor around how the API specification ends up in your central repo. And now that you have this certainty that you have really high quality API specifications in a central source of truth, you can now feed it to Specmatic. And then once you do that, you already know this. I could take an API specification, and for the consumer, I can run a mock server, just like I showed you that I could take an async API spec and run it as a Kafka mock and start building against it. I don't have to wait for the provider to be built in order for me to, use that as a sandbox or maybe to get it deployed to a integration environment and then use that as a staging environment or an integration environment. I can independently make progress purely based on the API specification, and the example data comes with it. Right now, it also means I can do fault simulation and whatnot. I could say simulate delays or issues with messages and stuff like that, which is harder to do with real applications, right? It might be difficult to go and say, hey, this other service should be down at that point. If you really had to do that in a real staging environment, I would have to introduce some sort of a complex proxy, test it, and the repeatability of the test will be very cumbersome. Instead, what you could do is just simulate that using your API specification based mark using Specmatic. And on the other side, again, the provider does not have to wait for consumers to be built or against it and test it out. You can independently make progress. You run the API specification as a test against your provider, and you've seen a lot of that today during the demo. And but however, in the interest of time, we couldn't get into the details of a concept called resiliency testing when we do run the API specification as a test. Now, resiliency testing is something that is inspired from for APIs is inspired from both property-based testing and mutation testing. What we mean by that is you take an API specification, you treat it as a feature, and when you treat an API specification as a feature, you can derive properties out of it, and then say these are the properties that needs to be satisfied by the system, and thereby I can generate tests, right? And thereby, and furthermore, what we can then do is mutation testing, right? In typical context, mutation testing would change the code and see if the tests are catching those mutations. In our case, what we do is we introduce mischief into the test data itself and say, what if I send a string to a boolean field or a number field? Does the application quietly accept it, which is very dangerous? And we see if there are enough input validations to figure out if your application is resilient to such sort of a spurious input, right? Now, again, a lot of the security research also points to the fact that a majority of vulnerabilities come from lack of input validation, and such sort of testing using which is based off of property based and mutation testing principles, the resiliency of the application can be guaranteed to a lot better extent instead of just relying on uh, you know testing much later in the cycle. You could do that purely based off of your API spec for free, generate those tests and move forward with that. So now this is all local machine, right? Like again, calling out to what Joel was showing, everything was on his local laptop and he was getting feedback. Let's move to the CI. So again, in the CI, now once you run unit tests, which is your staple, you could next immediately run component tests, right? And for component tests, you would need to isolate the system from its dependencies like Kafka and other things. Again, you don't have to look for a different way to mock Kafka, right? Pretty much the same Specmatic mock server that you were using on your local machine can run on CI also. It's just wire compatible, as we already demonstrated, and it is an executable, which means it runs in any environment. So that's as straightforward as that, and you don't have to do any additional effort at all. And that's the same for provider also, which is after you run your unit test, you run your contract test first and then run the component test to verify that the system is in order, which means all through this journey of both the consumer and provider, while they have not tested against each other, they have adhered to the API specification, which is coming off of the central contract repository. That means you have peace of mind while going to the integration environment that when you deploy these two systems together, they are pretty much going to be having no difficulties at all in terms of contract compatibility, right? They are already adhering independently to the spec, so thereby they're adhering to each other and they're compatible with each other. Now, that means you have a clear path to production and a lot of peace of mind, right? You don't have to have sleepless nights. And all of us deserve our beauty sleep, I believe. So we should just catch issues as much as early as possible. And which is what is being demonstrated here by the heat map. The bar at the bottom shows green all the way in the left and then crimson to the right. You do not want to be in the crimson side because that's the more expensive side, right? Identifying issues on the right, which means like people who have built those features maybe have moved on to other pieces of work, and now for them to context switch and fix this bug and then move back to building what they were building, that's all really really expensive. Instead, you want to catch the issue when the issue is in its earliest of stages, and we want to shift it all the way back to design, right? Like that's the whole emphasis on no code. Even when I'm unintentionally introducing a breaking change right at the spec level itself, and I'm designing an API change, right then I want to catch it instead of actually having to build code and then have to realize that's a problem. So that's the power of being able to shift all the way to the left to the API design stage. Now, this means you have excellent developer experience. First of all, you're not having to work and rework on things that could have been like caught earlier. So you already caught breaking changes much earlier. And when you're building your applications, any amount of drift, whether you're a consumer or a provider, you get feedback on your local machine, and that's beautiful because I do not want to be on the wall of shame of the broken CI build, right? I want to be able to identify issues and fix things as soon as possible and be as productive as I can. So that's beautiful DevX, and I do not have to write code to generate tests. And this is all dynamically getting generated for you in terms of tests or your mock behavior. And of course, reduce time to market because of the parallel development. As you've already seen in this diagram, the consumer doesn't depend on the provider doesn't depend on the consumer to be coming online. We both teams can make progress, and this is crucial because in a even a mid-sized organization, the user experience layer all the way to the data layer, you may have like 4 or 5 layers of components which come together to create a feature, right? Now, if we have to say one has to be built for the other to be tested, then we are never going to get features live into production in time. What we want to be able to do is independent progress and with confidence so that we can build and deploy applications in isolation while still being sure that they are compatible with each other. And this is a really, really important, requirement from a business point of view so that you have the advantage in terms of moving to shipping features quickly. And of course, while we are at it, we want to build resilient API blocks, right? Like I said, the fault simulation, which you can do with a mark, I could simulate delays, and also with the fact that you can generate a lot of tests and spurious input and verify that there is sufficient input validation in place. You are ensuring that your applications are actually built not just to spec, but also if there is anything beyond the spec, the application can handle and doesn't fall over, right? And make sure you have resilient API building blocks. So that to us is the $1 million slide. I'll leave you with this here so that you can think about this in terms of the governance. And we believe this such governance is absolutely essential at the bare minimum to make sure that you have a proper API lifecycle within the organization. And with that, I'll thank you all. You've been a great audience, and this is Hari and Joel signing off. Thank you very much.